Welcome to a lesson with Dr. Powell. Let's take a look at the example that we had where we were doing a line integral one way and another way, and we ended up getting like a potential function. And let's use the idea of how do we know we have a potential function by looking at the curl of the line integral that we're dealing with and verifying that it's equal to zero. Because if it's equal to zero, then we will have a potential function. Or an antiderivative rather, and be able to integrate it just fine. Let's take a look and see what that looks like in this particular case. So if we have our function, remember, was f of z is equal to z. So z could be thought of as just x plus iy. But then when you're integrating the differential, you take x plus iy and you multiply it to dx plus I dy to get the line integral that we're after and we're interested in. So let's take a look. Let's take a look at that line integral. So we end up getting, let's see, it's x plus iy dx, and then plus, and then we have a minus y plus ix dy. Okay, so that's and that's what we'll be integrating here. But we break it up into imaginary and complex, and imaginary and real parts here. So we end up getting x dx minus y dy plus factor of the I y dx plus x dy. All right. Now, when we end up taking the curl, we end up getting from here, because of reversal of directions, when we take a, when we go here and take the curl, notice that the curl ends up simply being, well, here you just have a dx, and here you have a dy, and so those guys actually go away. The curl of this part is simply zero. In this part, let's take a look what happens. We actually get a dy dx, and here we get a dx dy, but here's the reversal of the order. And so if you add them together, dy dx plus dx dy, you end up getting zero, since this part would be negative. So we actually do get a curl of zero. It's kind of interesting to see that. Another way of detecting that curl is zero is seen by looking at by actually looking at the derivative of z itself, and as a vector, actually with a vector output, so x and y output. And in particular, it has an x and y input too, because this is such a simple thing. So x and y input and x and y output. In fact, the matrix is just a 1, 1, 0, 0. Very simple matrix, and it's representative of the complex number 1. In fact, if you take any complex number like at all, a plus bi, and thought of it as a vector like this, and you multiplied it, you would end up just getting a plus bi back. In other words, the derivative is behaving like a complex number. If the derivative behaves like a complex number in multiplication from the matrix, then actually the curl will be zero. Why is that so? Let's take a look at that in the next video. Thanks for watching.